Hi everyone, this is Jayashree, Assistant Professor, Department of IoT. Today we discuss upon different types of registers. Okay, so to begin with, what is a register? What is shift registers? And what is universal registers? So these are all the topics we are going to discuss in this video, right? So register is an element which stores data. It registers data. We call it as a register. It is a basic element in any memory circuit, in all digital circuits. It is a basic element. It is made of flip-flops. The previous lectures we discussed upon various flip-flops. Here, an array of flip-flops is used to store many bits of information. So that thing we call it as a register. Okay. So what is a registers? So flip-flops can be used to store a single bit of binary data, either it is a 1 or 0. So in order to store multiple data, there are multiple flip-flops are used. Okay. So n flip-flops are to be connected to store n bit of data. Okay, for 16-bit, we need 16 flip-flops like that, right? But there are different types. We'll discuss upon one by one various registers. So register is a device which is used to store such informations. It is a group of flip-flops connected in series used to store multiple bits of data. Okay, so here this is an example of a 4-bit register. Okay, to store 4 bits, 4 D flip-flops, no, SR flip-flops are used here. Okay, so this is a 4-bit register, what you are seeing in this diagram. Okay. Then we discuss upon various types of registers. So what is a shift register? Shift register, it shifts the data bit by bit. It shifts, either it is shifts left register, it shifts the data to the right. So that thing we call it as shift right register. There are ring type registers. Okay. So from the, we are taking the output of the both last flip flop and we give that information is given to the first flip flop. That type of flip flop registers we call it as a ring registers. The data starts moving. That thing we call it as a ring registers. So here there are with that note we discuss upon different types of shift registers. One is SISO. We call it this is serial in, serial out. So that thing SISO. Second one is SIPO, that is serial in and parallel out shift register. Third one is parallel in and serial out, PISO, right? Then fourth one is parallel in and parallel out. So information comes in parallel and output is also goes on parallel. So that is parallel in and parallel out shift registers. Okay, we discuss upon one by one. So first is look into this picture, serial in and serial out. Okay. So in the first flip-flop, the data enters to the terminal D. That is input is C. It enters into the first flip-flop. The output from Q is given as input to second flip-flop. Then output from second flip-flop is given as input to first flip-flop. So the information is coming in, the data input is coming in serially, line, it is coming serially. Then the output we take from the last fourth flip-flop, it is a single output, single input, single out. So here, this register is a synchronous register. See, the clock pulse are given synchronously. So once the clock pulse is given, all the flip-flops are shifting the data to the right. Okay, this is serial in, serial out shift register. So look into this picture. Initial values 0, 0, 0. That is the output of all the 4 flip-flops. So the output from the fourth flip-flop is also a 0, right? And after one clock pulse, what happens? The data 1 enters into first flip-flop, whereas the data from QA shifts to QB, QB to QC, QC to QD. Then after second clock pulse, the first, that is QA, the one is shifted to QB. Then 0 shifted to QC, this 0 shifted to QD. Then again 1 enters into the data, that is QA, that is first flip-flop, the data 1. So with this, the one which we give at the first clock pulse, it reaches QD, the value 1, it reaches QD after fourth clock pulse. So 4 clock pulses are required to transfer the information from first flip-flop to fourth flip-flop. So this is the time delay. It takes some time delay. This is serial in and serial out shift register, right? Similarly, next one is serial in and parallel out. So see here, the input is serial. It enters first, second, third, fourth, but we are taking output from the first flip-flop. QA we are taking as output, QB we are taking that as output, QC we are taking that as output, QD is also taking as output. So there are 4 outputs, 1 input, and also it is also a synchronous circuit. So clock pulse is given simultaneously to all the flip-flops. So this is SIPO. Look into this picture waveform. So when the clock pulse is given, the bit, the information is transferred. So this is serial in, but the output, see the output, we are taking all the 4 outputs, n-bit output. If it is a 4 flip-flop, 4-bit registers, there are 4-bit output in this registers. So with this, next 2 flip-flops we'll discuss in the next class. So in this class, we discuss upon serial in, serial out, and parallel in, serial in and parallel out registers. Thanks for watching. Thank you.